Today we're taking a look at question 6 from the FP1 June 2016 paper. So this question is about matrices and transformations. So let's start this one. So part A, it tells you, or asks you to describe fully the single geometrical transformation U represented by this matrix here. So this just comes with a bit of practice, but straight away you should be able to recognize that this is a rotation. So it's a rotation. I'm just going to put rot. And the amount of degrees this is just 135 degrees anti-clockwise. Again, this is anti-clockwise. You could have done this clockwise, but make sure obviously you change your amount of degrees. So this is just a rotation, so you get 1 mark for saying it's a rotation, and then the second for it being 135 degrees anti-clockwise, or similarly the amount of degrees clockwise. So that's just part A done for 2 marks, nice and easy. Part B, it tells you that the transformation U maps the point A with these coordinates PQ onto the point B with these coordinates. And we're asked to find the values of P and Q. So there's a couple of ways you can actually do this. I think the easiest way of actually doing this is think about taking the inverse of this. Well, if I take the inverse of P here, so if I do P inverse, and I times it by these coordinates here, so if I represent this in a matrix form, that's 6 root 2, oops, 6 root 2, give me a minute, my mouse is dying, there we go, 6 root 2, and 3 root 2, like that. Well, this is going to be equal to the points P and Q, right? Which is going to be P and Q, like that. Well, if you perform this calculation, P inverse, so that's the inverse of this matrix, so you'd have to do 1 over the determinant times by the adjoint. Now, for these questions, you can do it on your calculator, but make sure you show the previous bit of working, just so your examiner's clear what's happening. So if you actually do this on your calculator, you obtain this matrix, minus 3, minus 9, and therefore this implies P is minus 3 and Q is minus 9. Like that. For part C, we just have to... oh no, my mouse isn't working. There we go. So part C, we have to write down the matrix Q here, and it tells us the transformation V, represented by the 2 by 2 matrix Q, is a reflection in the line with equation y equals x. So again, it's just one of these that you're going to have to learn. The way I like to remember this one though, for this reflection, is I like to think of it as the opposite of the identity matrix. So if I say Q is equal, so if the identity matrix is 1, 0, 0, 1, then the opposite to that is going to give me 0, 1, 1, 0, like that. So you sort of shift the identity along. So actually 1 mark for part C. For part D, we've got a transformation here, U, followed by the transformation V, is the transformation T. And it tells us the transformation T is represented by the matrix R. And we have to find this matrix R. So you've got to be very careful the order that we do this. So R, here in this case, so R is going to be equal to Q times by P. Be very careful on the order. Remember, matrix multiplication, so QP is not going to be the same as PQ, or it's very, very unlikely. So you have to get this order the right way around. If you get the order the wrong way around, this is going to fall apart. So R is going to be equal to the matrix Q, which is what we've just worked out here. So that's going to be 0, 1, 1, 0. And then it's going to be times by the matrix P. So remember, P is this matrix here. So this is going to be a bit messy. Let's see if I can write it out just about. Minus 1 divided by square root 2. Again, minus 1 divided by square root 2. 1 divided by the square root 2. And minus again. So, this is R now. Well, all you've got to do is actually perform this multiplication. So what you get now when you perform this multiplication is, obviously, if I did it by hand, you know, I'd get the calculations, and then you'd have to simplify each term. But again, you can do this on your calculator as long as you show this multiplication here with, you know, the matrices given. So this is going to be equal to, I'm going to get 1 divided by the square root of 2 minus 1 divided by the square root of 2 minus 1 again divided by the square root of 2, and then minus 1 divided by the square root of 2. And that's part B done. Part D, sorry. So just make sure you get the order of the matrices correct, guys. You get this one way around, it's going to fall apart. And then finally, for part E, we have to deduce that the transformation T is self-inverse. So what that means is this transformation here, R, if I do R times R, so R squared, which is going to be equal to R times R, if I perform that matrix multiplication, I should get the identity. And if you do that, guys, you do obtain it. So you've got to show this matrix multiplication here again right out fully, but you just got to show that this becomes 1, 0, 0, 1, which is identity matrix. And there we go. That's the full question done. Hopefully that's nice and easy. But yeah, there we go.